Good morning.
Go ahead.
It's always great when you get invited somewhere to talk about something brilliant and creative you're doing. Unfortunately, this isn't one of those things. This is all about coping. This is an ongoing exercise in coping with a set of conditions we didn't really create, but we have to recognize and somehow figure our way through. So I'm just going to start with kind of quick intro about the Denver system. I won't go into too much detail. Basically, it's a system that was built out of a consolidation of a series of private systems in the early 1900s. Serves about half the metropolitan area of Denver, about 1.3 million people. It's a pretty extensive collection system, 2.5 million acres, 4,000 square miles. Has a pretty large footprint on the state of Colorado, and operates 19 raw water reserves. So this is a picture of who we serve in the metropolitan area. It's basically the city and county of Denver, and then a lot of the southern and western suburbs. And we draw water from a variety of places. Parts of the upper Colorado, the Williams Fork, Blue River, and Fraser Rivers. And then also a big chunk of our system draws water from the South Platte on the east side of the Continental Divide. And that distribution is important. As you can see in this chart, basically only about 20% of the water really comes to the northern side of the system. So about half of it gets generated in the south side in that South Platte Basin, or it comes from the west slope through tunnels through the divide and comes into the system on that south side. So when you have major forest health issues and catastrophic fires that knock out facilities in that south side of the system, the implications are much bigger than just the pure math. In terms of demand, this is kind of what's been happening. We've been doing reasonably well. We've added about 300,000 people to the system and used less water than we did in the 1980s. Still a long way to go, but good progress. Same with the peak day. As many of you in the room know, the peak day has a lot to do with the scale of your system, and so we've been driving down those peaks from 5 and 550 million gallons a day. We haven't even seen 400 million in quite a while. But like the rest of the state, we're all challenged with the reality of population growth. This is Intermountain West, lots of change, lots of growth. And so even with relatively aggressive conservation scenarios, this is a slide from a recent statewide planning exercise, there's just realities that we're going to need to serve more people. So Denver water strategy is really kind of an all of the above. Our future is mostly about conservation and reuse of water. We don't really have a footprint in the ag world today. We may do some rotational fallowing and ag sharing kinds of models. We're doing a lot of tweaking of the system. The WISE project is a reuse project that shares infrastructure with a neighboring jurisdiction, uses their collection system, their treatment system, and delivers that reuse water that we can't use currently to suburbs in the south that are on wells that are about to go dry. And then one minor, relatively minor in the scheme of things, reservoir expansion. But it's really not about trans-mountain diversion and storage as much as it is about efficiency and enhancement. I would imagine our list of challenges looks like everybody's list of challenges if you run a Western water system. It's all the oldies but goodies: climate change, drought, wildfires, terrorism, water quality and regulatory requirements, in our case the Colorado River Compact, and growth, the reality of more people. So I'm going to talk about just one subset of issues, and this is basically our kind of learn by doing education in forest health and the realities of what it's meant for a system like Denver's. So I'd say pre-90s, we had seen wildfire in the system, certainly, but really the patterns began to change. And the Buffalo Creek fire was the first one that was really a game changer. This was a 12,000 acre fire. It just happened to be in the right place at the right time and was followed by a 2-inch rain event 60 days later. It's changed our world and continues to change our world. And then in 2002, we had at that time the biggest fire ever in the state of Colorado, 138,000 acres, and that burned over the main heart of our system, including some of our major facilities. And we've continued to have fires and rain events. Most recent fire was 2012. This was actually a prescribed burn on our land that the State Forest Service was conducting that got out of hand. Did not actually create as many issues for the system, but there was loss of life, loss of property, raised a whole bunch of issues about forest management again. So we've spent somewhere in the neighborhood of $30 million so far just dealing with the consequences, coping really with the consequences of these activities. And the impacts aren't done. They continue to this day. And none of that puts us on offense. That's just defense. That's just coping. So I don't know how well you can see this, but this is an image that basically shows the outline, footprints of those fires and some of the others that have occurred. And these are all pretty much in the Ponderosa Forest, Front Range, Colorado, South Platte Basin, really the heart of our system. So this is the Buffalo Creek fire, and this was really the one that started all this. It's amazing. You know, this event really occurred in about 5 hours. Fire moved 11 miles, burned that 12,000 acres, and then a thunderstorm stalled on that location 60 days later and moved a decade's worth of material into our system in one day, one afternoon. And so these are just images from that period. This is some of the debris that flowed into Sarancha Springs, which is one of our reservoirs. I mean, obviously, our guys had the luxury of really operating a system that mostly deals with very pure water, you know, high elevation snowmelt. They've never seen stuff like this. They don't get refrigerators showing up in the reservoir, and or this amount of material. And as you can imagine, all kinds of things changed. The amount of metals and turbidity and organic carbon and dissolved oxygen, just parameters we've never experienced. 15 surface acres of stuff that took months and months and months to pull out of the system and shut down this reservoir and shut down the biggest treatment plant in the system while we were trying to cope with it. And so that was the event. But basically, these events have continued to occur because every time it rains, we don't get a lot of rain, but it doesn't take a lot of rain. It just triggers this system again and again. And so that's really part of our challenge now. It's also pushed all this material into this particular reservoir, so it's really changed the nature of the reservoir. It's accelerated, you know, the sedimentation of this facility, and we've struggled with that as well. And it's not just a loss of capacity, but this material tends to want to move to the face of that dam, and so it has operational implications, it has structural implications. It's a big problem. This is a picture from the Hayman fire. That's Cheeseman Reservoir, another reservoir in our system, an even larger and more important reservoir. The fire burned directly right over this area in the heart of that 130,000 or so acre fire. And basically all the tributaries in this area became problematic overnight. And so we've been out building kinds of jerry-rigged and improvised systems to try and control sediment that wants to keep moving down into this system, down into the river. It's also impacted infrastructure in this entire area, the amount of erosion that's going on. These fires are unnatural fires, and they burn at really high temperatures. They don't revegetate very easily, and so the world stays in this condition much longer and is much more vulnerable. And so all kinds of implications for water quality. This was 2009. This wasn't even related to any kind of fire event. It's just every time it rains, we see these kinds of conditions. And this is what you see. There's still tons and tons of debris and sediment that are just stuck in certain places in that system waiting to come down. It's still all loaded up. So this is one of a series of check dams that we've built on tributaries that try to control sediment. And we've done some of these on emergency permits because we didn't plan for these. They had to be built overnight, and that's not an easy thing to do. Basically, they store sediment, and then we have to come in and take it somewhere. We spend $250,000 every time we empty one of these, which is crazy. It's just a perpetual motion machine. It fills up, we take it back to the top of the hill. It fills up, we take it back to the top of the hill. It doesn't really make any sense, but it is what we have to do because we have no other way to control this volume of material. And every once in a while, the volume triples. We had a year where it just skyrocketed. So we've spent, at this point, about $11 million just doing those kinds of things, check dams and sediment removal and just, again, just sort of coping. This is the nature of this. So we dig rocks out to make the check dam, and we put the sediment back in the hole where we dug the rocks out. That's the sophisticated engineering that's going on here. And then the reservoir itself, we have a building full of engineers, as many of you do, so they of course had a desire to get some of that material out because they were worried about what it's going to do to that dam ultimately. And so we investigated a lot of different options. It's up a very pristine and very sensitive mountain canyon. It's not an easy place to get into. We looked at all kinds of options, but ultimately came up with a solution that was a dredging operation that would slurry that material down that canyon and take it out at the bottom. Only one firm was up for that task. They came, they worked very hard at it. and they were out there for quite a while. It turned out they weren't really able to remove the quantity of material they hoped, and so we only got about a third of the material out of there. That's helpful, buys us some time, doesn't really solve the problem. We don't really know what the answer looks like here, if there is an answer. So it's made it better, but it didn't really solve the issue. Meanwhile, we're in this landscape, and of that 2.5 million acres of our collection system, about 2/3 of that is federal land. It's mostly Forest Service land. Another 900,000 acres is private land, so we own almost nothing in this giant watershed and collection system. And so we're trying to figure out how to manage these conditions on land that we don't own, which makes us inevitably partners with the Forest Service. So these are the kinds of treatments. I mean, basically the fundamental problem is you have a ponderosa forest that is full of fuel and way denser than it ever was historically. It's going to burn, and it's going to burn catastrophically. It's not going to burn in a normal fashion. And once it does that, it's going to send material into our system forever, basically. And we have to try and get in front of that, but nobody has the resources to fix that forest. So we've been trying to figure out where's the greatest risk and how do we mitigate those risks. And this is a good example. This is basically straw bale check dams. We've bought out every Home Depot in the region multiple times to run up here and do things like this on a moment's notice. And but it shows you, basically that's Denver water property, that's Forest Service property, what we're able to do early on, short notice. And contour felling, trying to really put any obstacle in the way of sediment moving that we can. These racks, salvage logging. I mean, basically, at the end of the day, what the world really needs is a less dense forest that will burn more naturally. But it's tough to get back to that. And so this is ultimately a place that has some of the right ingredients, but obviously it's already burned. So this is an indication of what we're facing. This is around that Cheeseman Reservoir. This is what it looked like in the 1900s. Pretty open, lots of small parks. What people believe to be a fairly natural ponderosa forest for this area. You can see the bottom picture in 2002. That's what the Hayman Fire burned, those trees. And one interesting little experiment, which we didn't really intend to be an experiment, this is right at the Cheeseman facility. We had actually done some forest treatment around some of our facilities, caretaker's house, other facilities. You can see on the hillside there, that area basically was not treated. That's how it burned. And the little area on the right is the area that had been treated prior to the Hayman Fire. It burned in a pretty natural fashion and is already back to reasonable health. This is the North Fork area, where you can see kind of the difference between areas that have been thinned and treated versus the areas that are really in this kind of current overgrown condition. So this is kind of the evolution, forests that look like this, trying to work their way back to forests that look more like that. That's a forest that we can probably live with in the watershed, but what we've got right now is tough. And then a whole different set of issues on the other side of the Continental Divide. The other parts of our system are in the lodgepole forest by and large. That's subject to beetle kill, so there are maybe 2 million to 3 million acres of dead and dying trees over there. Again, with the same, different dynamics, but same fundamental problem. Those watersheds are prone to potential fire risks now. And it's really wiped out just an enormous amount of acreage, and again, the scale, very daunting. So we've been working with the State Forest Service and with the U.S. Forest Service for quite a while, but I don't think we really realized the depth of the problem until we saw some of these events and realized this is what our future is going to be about. And so we started down this path with the Forest Service in 2010. Essentially, the initial agreement is a 5-year agreement. We reimburse them for work they do, and then they also match that and do work, and we get to pick the areas that are of mutual interest. So essentially, our goal in this initial go-around is 40,000 acres of the highest risk locations for us. Things that are right on top of our facilities, steep slopes, highly erodible, lots of fuel, or present other immediate risks. So this is just an example of the kind of work that went on in that 2.5 million acre collection system. We really had to go through every part of it and kind of analyze what are the conditions here. And so, as you would imagine, red is bad, blue and green are better. If it's red, it's a place we need to try and focus on soon. This is, you can think of this as a big, expensive, not very good insurance program, because what it's doing is taking the worst possible locations and trying to mitigate them. It doesn't mean the next worst location doesn't get hit by lightning and burn and cause all the same problems. And so you can't really eliminate the risk. You can maybe shave off the probability somewhat, and that's really what we're starting to do. And truthfully, we all should have been doing this for decades, but that's not what anybody was doing. And so I don't know how well you can see the cross-hatching here, but basically out of that analysis of all those zones, these are the ones that rose to the top, and these are the priorities for that first 40,000 acres where we're trying to start to make a dent and make some changes. And also, frankly, sort of pioneer the relationship where routinely we can get out there on federal land, not just doing things on our property, which doesn't really matter. It's really the national forest, and trying to get accustomed to working with each other and making some inroads here. So we're kind of into the third year of this. About 25,000 acres have been addressed or are under contract now to be addressed. It doesn't come out evenly in terms of whose money goes where. Some acres are more expensive than others depending on what we're doing with them. It's everything from treatment to try and thin the forest and manage it to restoration of areas that have to be dealt with. The other thing we wanted to do by being participants was encourage other utilities. Everybody who has a system that uses the national forest has the same issue. And so I think our moving forward with the Forest Service did encourage other entities to start to think about that as well. So Aurora, a neighboring jurisdiction, has spent some money now on restoration and is starting to spend money on treatment. Colorado Springs is entering into an agreement. Northern Water has a pretty ambitious 5-year plan that they're working with the Forest Service on now. And Pueblo is starting down the same path. So I think inevitably, I think you will see all those major front range water users who rely on this watershed and this forest, or these forests, participating in activity like this. The other part of our activity that is somewhat relevant, we were part of a 5+ year mediated negotiation between Denver Water and about 36 West Slope entities, headwaters counties, all kinds of water and wastewater entities, ski resorts, the Colorado River District. And the goal was essentially global peace, was really to figure out what's the ultimate footprint of our system in their world, what's our commitment to managing their resources and helping them, and basically both of us working on bigger issues rather than the historic fights we've fought for the last 20, 30, 40 years. And so it was a long and drawn out and sometimes difficult process, but it did actually yield a result. And there is a cooperative agreement that almost everybody has signed now that really is kind of a new framework for how we work together. And embedded in that are lots of things, but this is just a couple of them that relate to watershed management. Now this is California. You need to add a 0 to everything here to relate it to your world, but basically this is the start of a long-term process of us as a water utility investing in those natural resources on the other side of the divide with those communities. And so it's stream management and habitat and restoration and forest health and a whole variety of issues that are important to them and to us in the long run. The other thing we did out of this agreement, there are cases where we make short-term leases or spot sales within the metropolitan area and also reuse water that we are making available to other jurisdictions outside of our current service area. Under this agreement, we impose surcharges on all of those that flow back to the West Slope for more of this kind of watershed investment. And so it's creating really a long-term revenue stream essentially for them. They get to decide. We set the parameters of what kinds of things are eligible, but they pick and choose. But in the long run, we're both made better off, I think, by making that investment. And it's a way for us to recognize that historically we've had a pretty big footprint in their world. We didn't always take responsibility for that, and we're starting to do that now. So that's our little experience. As I said, I wish it were something where we were brilliant and way ahead of the curve. In reality, we're way behind the curve and we're not brilliant. And so we're catching up, and we're catching up as fast as we can. But I think the world's still going to bring us more complicated and bad circumstances. We're going to still spend tens of millions of dollars on things that don't really make sense and don't create value for our customers. And we'll find our way through it. But at least we have the right partnerships. We've got most of the utilities, the land managers. There's a high level of recognition now that this is our reality, which wasn't there 15, 20 years ago. So that's progress, that's a start, but it doesn't solve the problem. And the problem is of such a daunting scale that it's tough every day to get people motivated to say, I know you're just fixing that 5,000 acres, but it matters. You know, sometimes it feels like that couldn't matter, but it's the only way we're going to get there. Happy to answer questions about any of that.